Okay, this problem says, given a sine or cosine parent function, I can create a rule that transforms the amplitude, period, and or midline. Okay, so A, what is the period of y equals sine of x? Now, we already did this problem. We worked this out on that paper, the transformations paper. So if you remember, the period of a basic sine or cosine function is 360 degrees or 2 pi radians. Okay, because that's just how long it takes to get around a circle, right? But if for some reason you couldn't remember that and you wanted to look at the graph, all you need to understand is that period is the horizontal distance from completing a cycle. So you put it in your graphing calculator. Let's see if we can get this screen to show it better. Okay, put it in your graphing calculator. Make sure your mode is what you want it to be. Let's choose degree mode. And then let's zoom 7, zoom trig, because this is a trig function, so a zoom 7 window is going to be good. So notice this kind of starts here and goes here, and that's one cycle. And then it repeats itself. So if I measure how the horizontal distance from here to here, where the pattern starts to repeat itself, that's one period. So I'm going to hit trace. Notice this starts at 0. How far do I have to go over before it repeats itself? Notice here I'm back at kind of a starting point, and I'm starting to repeat myself, so I went 360 degrees. If you had it in radians, it would be 2 pi or 6.28, something like that. So see, this is how I get the 360. Okay, now, what function rule would transform y of sine x so that its period was 3 times bigger? Now, if you guys remember, it's multiplying inside the parentheses that changes it. And if we want multiplying and dividing, and if we want to make it bigger, we actually, if we want the period to widen, if we want it to stretch out, we actually need to multiply by a fraction. Y equals sine of 1/3 x, like that. Okay? So remember, multiplying inside the function will change the period. It will stretch the function out horizontally. And and then you want to double check your work. You can just put, so sine of, and let's do a fraction then, 1/3 x, close parentheses, and let's see, we'll graph it. And if you notice, this is definitely stretched the graph out, right? And if we trace, starting here at 0, we're going to have to go over 3 times as far before we repeat ourselves. So here we've already hit, we're about to hit 360, and now we're going over, we still haven't repeated ourselves yet. We've got to go in the downward part of this pattern. So we're going all the way over. Now I'm at the place where I've repeated myself. See, this period is 1080, which is 3 times as big as this. So I remember that this is what does that transformation, and then I used my calculator to check my work. So moving on, what is the amplitude of y equals cosine x? So again, let's, if you remember, so I'm going to put cosine x. I'm still going to use degree mode, and I'm going to use zoom trig. But if you remember, the basic cosine function goes up to +1 and down to -1. So that means the amplitude, you take the difference of those two, right? How far apart are they, which is 2, and then you take half that difference, it's 1. So if you remember, the basic trig functions, sine and cosine, have amplitude 1. But if you didn't remember that, again, you can do zoom trig on your cosine function. And remember here, you have a maximum of +1, right? So amplitude is about vertical, right? Not horizontal, like period. So maximum of +1, so we're looking at our y's, and then you go down here, you've got a minimum of -1, right? So max equals 1, min equals -1. So amplitude takes 2 steps to go between those, and half of that is 1. So that's how you get the amplitude. Now you want a function rule that would transform cosine x so its amplitude's 3 times. So remember, multiplying on the outside of the function changes that, and it's what you would expect, multiplying straightforwardly. So notice inside, if you wanted to make the period bigger, you multiplied by a fraction. But outside, if you want to make the amplitude bigger, you multiply by the integer number, right? Now, you can test this out by putting in the 3 and graphing again, and now notice what happened. This goes all the way up to positive 3 and all the way down to negative 3. So again, that's 1, 2, 3, 4, 5, 6. There's a difference of 6 vertical distance, and half of that's 3. So we know we checked our work. Our new amplitude is 3. Okay, so just as a review, multiplying on the inside of the parentheses changes the period. Multiplying by a fraction makes the period bigger. Multiplying by a number bigger than 1 makes the period smaller. Then multiplying outside the cosine or sine function is what makes the amplitude change, vertical stretching, right? And so multiplying by a number bigger than 1 stretches far. Multiplying by a number smaller than 1, a fraction type makes it smaller. Okay. Midline of sine of x. So again, hopefully you remember a basic sine function has a midline at y equals 0. That's the one we're most used to seeing, right? But if you don't remember, you can graph it. Remember, the midline is the line that cuts through the middle of the function between the max and the min. So again, the sine function has a max at positive 1, a min at negative 1. The number between that is 0. So the y equals 0 line is what cuts through the middle of sine x, right? Now, what function rule would transform sine x so that its midline was moved down by 4 units? So remember, the kind of transformation to a rule that moves things up and down is to add or subtract on the outside. So we have y equals sine x, but we want to move it down by 4. Now, we wouldn't put that in parentheses or it would move it left or right. But putting it outside of the sine function, down 4. And if you want to check yourself, again, put it in here. Let's look at the graph. And notice it moved down. We can't even see part of it. But if you notice 1, 2, 3, 4, that's right the middle. This kind of cuts it off right at the middle. You could make your window different or zoom out. But we can kind of tell this cut it off in the middle at 1, 2, 3, 4, at negative 4. Okay? So our new sine function has a midline at y equals negative 4.